Well, in the previous videos, we did question 1.1 with all the sub-questions, question 1.2, and now we're going to do question 1.3. Now, it is given that the question abnormality of question 1.3, it is given that if 3 to the power of 9x equals 64, and 5 to the square root of p equal to 64 also. Now the question says calculate without the use of a calculator the value of 3 to the x minus 1 to the power of 3 over square root of 5 to the power of square root of p. Oops. We need to find this value. All right, the question looks challenging, tricky, but now let's see. Let's think all together. We have like 3 to the power of 9x equal to 64. Okay. If we said let's write the numbers in terms of the prime factor, on the left it's already the base is already in terms of its prime factor, but now on the right 64. In terms of its prime factor, it will be 2 to the power of 6. Okay? That's correct, because if you're unsure, you can just press in the calculator, press 64, okay? Press equal, and then press shift, and then press the fact button, this button here. Let's do it over. You press 64, equal, and then you press shift the button, and then you press the fact button. So it tells you that 64 is equivalent to 2 to the power of 6. Okay, first of all, we notice that because 3 to the power of 9 to the x equals 64, and then 5 to the power of square root of p equals 64, this means that 3 to the power of 9x equal to 5 to the square root of p. But we cannot prove it because the bases are not common. And then we cannot also tell the exponents are the same. Now, we did here we try to reduce this. We have like 3 to the 9x equal to 2 to the power of 6, but the bases are not common. What can we do then? Sometimes if the bases are not common, we can also see if the exponent will be the same. Okay? Now, we can reduce this. 3 to the 9x can be written as 3 to the 3 times 3x, okay? So this is equal to 2 to the power of 6. Even 2 to the power of 6 also can be written as 2 to the power of 3 times 2. Now, why am I writing that? Because we do know this property that says that a to the m, O to the power of n is equivalent to a to the m times n. So we can write it in this form, okay? This can be written as 3 to the power of 3x all to the power of 3, okay? Following this law of exponents. Now, 2 to the power of 3 times 2 can be written as also as 2 to the power of 2 all to the power of 3. Now that we managed to make the exponent common, meaning we can equate the base, so we can say 3 to the power of 3x equal to 4. Okay, we got that part. It can help us because I can see here we have like 3. Let me first explain this part so you can see it clear. So this one can be written as 3 to the power of, because applying the same law of exponents, okay? Meaning we're going to times the exponent. So we're times 3 with this exponent. So this will be 3 to the power of 3 times x minus 1 all over square root of 5 to the power of square root of p. Now, I think I have an idea. Okay, We need to find x then. How can I do? Can we use the logs? If we use the logs, the question says, yes, we can use the log to calculate this, but the question says without the use of a calculator. So it's not going to work with the logs. I mean, it's going to work, but not for the equation. Okay. Now, what else they say? What else we know from the question? We do know that it is, when I look at the denominator here, we have like a root 5, but here it was given 5 to the square root of p equal to 64. But here they tell us square root of 5 to the power of square root of p. Okay. I'm going to split this code like this. If I look at square root of 5 to the square root of p, this can be written as, square root of 5 can be written as like 5 to the power of a half, okay? It can be written as 5 to the power of a half to the power of square root of p, okay? So we can also apply the same law. This can be written as 5 to the square root of p to the power of a half. It's the same thing because multiplication is commutative, okay? We can multiply like that. Now, we do know that 5 square root of p, 5 to the power of square root of p is equal to 64 to the power of a half. Wow. And then 64 to the power of a half is just 8. If you want to prove it, just know square root of a half. I mean, a half is like square root of 2. Or you can write 2 to the power of 6 times a half, and then you get 2 to the power of 3, which is 8. Now we can say root 5 to the root p is equal to 8. Oh, then we can solve this problem. Now we can do this. Okay. We had 3 to the power of 3 to the power of x minus 1 over square root of 5 to the power square root of p. Okay. We can split this word like this, and then write this will be equal to 3 to the power of 3x minus 3 over 5 square root of 5 to the power of square root of p is just 8, as we find it here. This is just 8. And this will be like, okay, I can substitute here. I'm going to substitute in the next line. So this is going to be like square root of 5 to the square root of p. And then this will be 3 to the power of 3x is just 4, as we find it there. So this is 4. Oh, no. We cannot do that yet. This is what we can do. This is like 3 to the power of 3x times 3 to the power of -3 over square root of 5 square root of p to the power of square root of p. And now we did say that square root of 3x is 4. So we can substitute there 4 times 3 to the negative a half is 3 to the power of -3, I mean, is just 1 over 3 to the power of 3, right? And then over root of 5 to the power of p is 8. So this is like 4 times 1 over 27 over 8, which is like 4 over 27 over 8. Now we have like a fraction over another fraction because 8 here is like, it has a denominator of 1. So over here we can write 4 over 27 times 1 over 8. And then we can solve this by simplification. If we simplify, we can see that 4 gets into 8 twice. So I'll leave 2 there and then 1 there. And then this will be equal to 1 over 54. Yes, we managed to do it. Okay, thank you. So done. If you have a question, you can leave in the comments here. Thank you.